All right, today we're going to explore the different types of reactions you'll encounter and the patterns you can use to identify that type of reaction. You're going to be able to need to know you're going to have to be able to identify what type of reaction is taking place based on the formula presented. So pay very close attention to the patterns I'm showing you. Okay, first type of reaction is synthesis. So synthesis is when you combine two or more elements or compounds and turn it into a single thing. So basically you got a single thing plus a single thing that combines to form a glomp. Or think of it as you got multiple stuff on one side and only a single thing on the right side. Also, if you go to the link, the notes on Google Slides, I got videos showing each one in action if you are curious or just want to be entertained. Okay, decomposition. Decomposition reactions break down. Think decompose. So you start with a glomp and it breaks down into different pieces. So for example, hydrogen peroxide, you know, the stuff that's in the brown bottle, when it's exposed to light, hydrogen peroxide breaks down into water and oxygen gas. Okay, single displacement. Single displacement. So one element changes place or replaces another. So here we got a red with a blue, and then we add in a yellow. Well, now the red's alone and the yellow and the blue are together. So think of it this way. You got a 2, a 1, followed by a 2 and a 1. So if you have like a group and a single element on one side and a group and a single element on the other side, that is a single displacement. And this picture kind of explains what's going on here. So here's a video of an example of a single displacement reaction. Go to the Google Slide links to watch this. Hopefully it works. If not, let me know and I'll find the YouTube video for you. And then this is just another example of a single displacement. You can tell in the formula because we have an element and then a compound, and then there's a compound and an element on the other side. All right, double displacement. So this is when two ions switch places, or if you're dancing, you're switching partners, or you are on a double date and you switch dates. So here we got a red and a blue together. We have a yellow and a green together. And now the inside pair switches and the outside pair switches. Oh, this looks like foil. First, outer, inner, last from math. I won't show you that. So yeah, inside pair switches, outside pair connects, like that. That's double displacement. And then again, a video showing you an example of a double displacement reaction. And in fact, a lot of the reactions that we will experience hopefully next week, if we get to do our precipitate lab, are going to be double displacement reactions. Okay, last type of reaction we will discuss this unit are combustion. And this one is a little bit difficult, but also kind of easy, because combustion always produces water and carbon dioxide gas. So think of the pattern. Don't care what's over here. You're looking here. If you have CO2 and H2O on the right-hand side, it is combustion. All right, and then just a couple vocabulary words. So inhibitors are things that slow down a reaction. Catalysts are things that help speed up an reaction. And then another piece of vocabulary, exothermic. So exothermic reactions release energy. They feel hot. So if you touch something and it feels hot, that's probably an exothermic reaction because it's releasing energy. And my pro tip to you, exo is like exit. So heat exits the system and you can feel the heat. Okay, the last piece of vocabulary and type of reaction are endothermic. Endothermic reactions take in energy. They feel cold because it's taking in the energy from your hand, from your feeling. That's why it feels cold, because it's taking in your heat, taking in your energy. And I don't know, maybe a nice way to think of it is endo sounds like in, so it's a system in heat leaving you cold, takes in heat to leave you cold. I don't know. Anyway, that's the type of chemical reactions.